Hey everyone, and welcome to This Explainer. Today, we're taking a deep dive into the incredibly high-stakes world of heavy industries. Specifically, we're looking at the oil and gas sector to uncover exactly how they manage to prevent catastrophic failures. We're going to walk through a comprehensive guide to asset integrity management, really breaking down those highly structured frameworks that keep these massive facilities safe, compliant, and most importantly, reliable.
Okay, let's dive into this. We're taking a macro to micro journey today. We'll start with the core of asset integrity, then look at building an AIM framework, jump into risk-based inspection, explore reliability-centered maintenance, compare the two, and wrap up with a look at the future of inspection.
Section 1, the core of asset integrity, which really is about going way beyond simple compliance.
To really grasp why this matters so much, we have to ask ourselves, what actually happens when just a single asset fails? Well, in heavy industries, one compromised asset can trigger massive unplanned outages. You're looking at staggering financial costs, lost production, severe safety incidents, and potentially devastating environmental harm. I mean, the stakes literally could not be higher.
So what are we really talking about here? Essentially, asset integrity is the ability of a physical asset, think a massive high-pressure vessel, an oil pipeline, a towering flare stack, to do exactly what it was built to do, safely and effectively. It's about ensuring that equipment doesn't fail, whether it's a normal Tuesday or during completely abnormal conditions, all while protecting the people and the environment around it.
Now, before we get into the specific frameworks, let's clear up a bit of industry confusion, because these two terms get mixed up all the time. Asset integrity is strictly about physical condition. Is the structure sound? Is it totally free of corrosion, cracks, or leaks? Asset reliability, on the flip side, is about consistent operational performance over time. So integrity means the structure is sound, reliability means it actually operates the way we expect it to. Both are absolutely crucial, right?
Moving on to Section 2, building an AIM framework. This is our strategic foundation.
Systematically managing this is what we call an asset integrity management, or AIM, framework. And the biggest takeaway here is that asset integrity isn't just a box you check once a year. It's a continuous, proactive life cycle. It starts literally at the drawing board with design and material selection, pushes all the way through installation, daily monitoring, intense maintenance, and doesn't end until the safety commissioning of the facility. It's the whole shebang. And honestly, executing that life cycle is an incredibly human endeavor. It's a huge multidisciplinary team effort. You've got inspectors, corrosion engineers, process engineers, operators, and maintenance crews, and they all have to collaborate constantly to evaluate data and make the tough calls on whether to repair, replace, or keep running.
Let's get into the tactics. Section 3, Risk-Based Inspection, or RBI. This is how we manage static risk.
So RBI is our primary game plan for static, non-moving assets. Things like pipes, tanks, pressure vessels. The entire concept is built around one wild but absolutely essential reality. In any operating plant, a very large percentage of the total risk is concentrated in a tiny percentage of the equipment. RBI is a smart methodology that says, hey, let's stop blanket inspecting everything equally and heavily prioritize our resources on those few, truly high-risk components.
And this brilliantly illustrates that paradigm shift. For decades, industries just relied on the calendar, checking a pipe every 5 years just because it had been 5 years. RBI tosses that out. Instead, we determine risk by looking at two things: the probability of a failure happening and the consequence if it actually does. You build your inspection plan based on a real criticality ranking, not just a date on a calendar.
The process itself is highly logical. It starts with continuous, relentless data collection. That raw data feeds directly into calculating those two paths we just talked about, the probability of failure and the consequence of failure. Combine those, and boom, you have a definitive risk ranking. That ranking then tells you exactly where, when, and how to inspect, followed by any necessary mitigation.
So to quickly sum that up, collect the data, evaluate the probability and consequence, rank the risk, develop a targeted plan, and mitigate. The payoff for this is massive. By zeroing in on high-risk items, facilities optimize their budgets, they safely extend the time between major turnarounds, and they significantly boost the overall safety of their static equipment.
Section 4, Reliability-Centered Maintenance, or RCM. This is where we master randomness.
But what about the stuff that actually moves? That's where RCM comes in. This framework is specifically designed for dynamic assets, rotary equipment, instruments, electrical items. And I have to lean into this fantastic quote from our sources. Maintenance professionals come to terms with the reality of randomness after decades in the bathtub.
For years, the industry bought into the bathtub curve myth, the idea that moving parts were predictably based on age. Well, RCM forces us to finally abandon that myth. Because the data tells a totally different story. RCM highlights these 6 patterns of failure probability. Now, what's really interesting about this slide is pattern F down at the bottom. It accounts for a massive 68% of failures across the board. And what it shows is that failure is completely random. It has nothing to do with how old the equipment is. Once engineers accept that randomness, they realize age-based maintenance just doesn't work for everything.
To tame this randomness, RCM relies on a pretty dense but absolutely vital tool called FMECA, which stands for Failure Modes and Effects Criticality Analysis. Don't let the acronym scare you. Basically, once you know what a machine is supposed to do, FMECA is simply the analytical engine used to figure out every single event that could reasonably cause that machine to fail.
So, executing RCM looks kind of like this. First, map out exactly what the asset's functions and performance standards are. Second, pinpoint all the ways it could fail to meet those standards. Third, run that FMECA analysis to find the root causes. And finally, put a tailored failure management policy in place. The whole goal is to create a hyper-efficient program by completely eliminating preventative maintenance tasks that don't actually do anything for random failures.
Section 5. Comparing RBI and RCM. 2 distinct paths to integrity.
So the crucial point here is how we juxtapose these 2 frameworks because they tackle very different physical realities. RBI is your heavy hitter for static equipment, right? It's all about calculating the probability and consequence of a failure to prioritize your inspector's time. RCM, on the other hand, is built for your dynamic, spinning, moving parts. It focuses on the reality of random failure through FMECA, aiming to just strip away all those ineffective, time-wasting maintenance tasks.
Finally, let's look at Section 6, the future of inspection. We're talking high-tech solutions.
Modern tech is totally changing how we execute these heavy-duty frameworks in the field. Both RBI and RCM are incredibly data-hungry. But how do you get that data without tearing a billion-dollar facility apart? You use NDT, or non-destructive testing. This includes super cool techniques like ultrasonic thickness measurements or pulsed eddy current scans. They let us peek inside the metal and find degradation completely harmlessly.
But the absolute game changer right now? Drone-based aerial inspections. Drones are the ultimate modern tool for asset integrity. You can fly them into incredibly hazardous or hard-to-reach spots, like a live flare stack, and get crystal clear data. No scaffolding required, no hanging guys from ropes, no shutting down the plant. It drastically cuts human exposure to danger while feeding perfectly consistent data right back into your RBI and RCM models. It's safer, it's faster, and it's just a vastly superior way to work.
Because at the end of the day, asset integrity is a relentless, continuous journey. So knowing the critical difference between managing static risks with RBI and random dynamic risks with RCM, you've really got to ask yourself, is your facility's integrity program actually ready for the future? Are you truly leveraging the right frameworks and these new high-tech tools to keep everything safe and running? It's something every professional in heavy industry needs to be thinking about. Thanks so much for joining me on this explainer, and I'll catch you in the next one.